Hi guys, welcome to another grade 12 video. Today we're going to be treating a different question paper. Let's get to it. Question 8. In the diagram, MP is a diameter of a circle centered at O. MP cuts the chord NR at T. Radius NO and chords PR, MN and MR are drawn. Angle R1 is equal to 69 degrees. Determine, giving reasons, the size of 8.1.1 angle R2. Angle R2 is equal to 90 degrees minus 69 degrees, which is equal to 21 degrees. Reason was angle in a semicircle, and the 69 degrees, we all know that R1 we were given. Moving on to 81.1.2, size of O1. Angle O1 is equal to 2 times 69 and it's equal to 138 degrees. Reason angle at the center is equal to double angle at the circumference. That's a theorem that you need to know. And moving on to 8.1.3 M1. Angle M1 is equal to 21 degrees angles in the same segment. And moving on to 8.1.4, size of angle M2. First, I went on to say angle O2 is equal to 180 degrees minus 138 degrees, which is equal to 42 degrees angles on a straight line. And I went on to say angle P is equal to angle O2, and they're both equal to 42 degrees. Alternate angles NO is parallel to PR. And I went on to say angle R plus angle M2 plus angle P sum up to give me 180 degrees. Reason, sum of angles in a triangle. Substituting in everything that I know, 90 degrees plus angle M2 plus 42 degrees is equal to 180 degrees. Angle M2 is equal to 180 degrees minus 90 degrees minus 42 degrees, and hence angle M2 is equal to 48 degrees. Pretty simple. Moving on to 8.2. In the diagram below, ABCD is a cyclic quadrilateral. AB and DC are produced to meet at E. AD and BC are produced to meet at F. Angle AFB is equal to 2x, angle DAB is equal to 3x, and angle AED is equal to x. Determine, giving reasons, the value of x. First, I went on to say angle D1 is equal to 3x plus x, and they're both equals to 4x, exterior angle of a triangle. And I went on to say angle D2 is equal to 180 degrees minus 4x, angles on a straight line. And I went on to say angle B1 is equal to 5x, exterior angle of a triangle. And I went on to say angle B1 is equal to angle D2, exterior angle of a cyclic quadrilateral. And substituting in everything, I know 180 degrees minus 4x is equal to 4x, and 5x plus 4x is equal to 180 degrees, and hence 9x is equal to 180 degrees, and finally x is equals to 20 degrees. Question 9. This is a problem where we have to prove a theorem, and we've already proved this theorem in our introductory lesson, in our theory lesson. If you've missed that, please go back and watch it. It will be very helpful. We've proved this exact theorem, the very exact same step, the exam style. Please go back and watch that. We've proved it the exact same way, and I'm not gonna do it again here. Just go and watch the previous video. I'm gonna jump straight into question 9.2, which the problem statement reads as follows. In the diagram, M is the center of the circle. A, B, and C are points on the circle such that AC is equal to BC. PA is a tangent to circle at A. PQ is drawn parallel to CA to meet BA produced at Q. BC produced meets PQ at R, and AR is drawn. Let angle Q equals x. 9.2.1. Determine, giving reasons, 4 other angles each equals to x. First, I went on to say angle A1 is equals to x. Reason, corresponding angles because PQ is parallel to AC. Angle B is equals to angle A1, and they are both equals to x. Angles opposite equal sides or base angles of an isosceles triangle. Angle A2 is equals to x, tan chord theorem. Angle P is equals to angle A2, and they are both equals to x. Reason, alternate angles because PQ is parallel to AC. Moving on to 9.2.2. Prove that ABPR is a cyclic quadrilateral. Angle B is equals to angle P, proved in 9.2.1. And hence, ABPR is a cyclic quadrilateral. Reason: converse of the angles in the same segment or angles subtended by the same chord. Moving on to 9.2.3. Prove that BA over BQ is equals to BC over QR. BA over BQ is equals to BC over BR. That is the proportionality theorem, because AC is parallel to QR, and I've highlighted the triangles that I'm referring to in my question paper. But I know that QR is equals to BR, sides opposite equal angles, as my reason. And hence, I have shown that I'm just gonna have to substitute that QR for BR, and I will have shown that BA over BQ is equals to BC over QR. And moving on to question 10. The problem statement reads as follows. In the diagram, TSR is a diameter of the larger circle having center S. Chord TQ of the larger circle cuts smaller circle at M. PQ is a common tangent to the two circles at Q. SQ is drawn. RP is perpendicular to PQ and MS is parallel to QR. Prove, giving reasons, that 10.1.1 SQ is the diameter of the smaller circle. Let's get to it. Angle Q1 plus angle Q2 add up to give me 90 degrees. Reasons: angles in the semicircle. Angle M2 is equals to angle Q1 plus angle Q2, which are both equals to 90 degrees. Reason: co-interior angles. MS is parallel to QR, and hence SQ is a diameter. Reason: converse of angles in semicircle, or angle in semicircle, is equals to 90 degrees. Moving on to 10.1.2. Prove that RT is equals to RQ squared divided by RP. In triangles RTQ and RQP, angle T is equals to angle Q3. Tan chord theorem. Angle Q1 plus angle Q2 add up to give me 90 degrees. Angle in semi-segment, or angle in semicircle. Angle R1 is equals to angle R2. Angles of a triangle, or sum of angles in a triangle. And hence I can conclude that triangle RTQ is similar to triangle RQP. Angle, angle, angle. And hence RT over RQ is equals to RQ over RP, proportionality theorem. Substituting in everything I know, RT is equals to RQ squared over RP, or cross multiplication rather. Moving on to 10.2. If MS is equals to 14 units and PQ is equals to square root of 640 units, calculate, giving reasons, the length of the radius of the larger circle. First step, I went on to say RQ is equals to 2 ms, which is equals to 2 times 14, which is equals to 28. Reason: midpoint theorem. RQ squared is equals to RP squared plus PQ squared, Pythagoras theorem. I've also highlighted the triangle that I'm referring to on the left hand side. Substituting in everything I know and making RP the subject of the formula, I will have RP squared is equals to 28 squared minus square root of 640 squared. And hence, RP is equals to square root of 28 squared minus square root of 640 squared. And hence, RP is equals to 12 units. But previously I've proved that QR squared is equals to RP, or RT is equals to QR squared divided by RP. Substituting in everything I know in this equation, RT is equals to 28 squared divided by 12. And hence, RT is equals to 196 divided by 3, and RT is equals to 65,33. Radius is equals to 196 over 3 divided by 2, because it's diameter divided by 2, and hence radius equals to 98 over 3, and hence radius is equals to 32,67. And I am done with that question, which brings me to the end of the lesson. If this video was helpful, please like and subscribe so that you don't miss upcoming videos. Until next time, take care.